All right, it's 5 minutes past 11, so let's get started. Carlos, can you hear me perfectly and you can see my PowerPoint? You can see my video? All good?
Yes, yes, sir. I
Perfect.
can hear you and I can see everything clear.
Sounds good. Let's get started. Welcome everyone to today's webinar on Python and StarSteer presented by ROGII University. My name is Ali Naqvi and I'm a technical analyst in ROGII tech support team and I'm based out of Calgary office. I am excited to guide you through how we can leverage Python in StarSteer to enhance our geoscience workflows. I have my colleague Carlos with me. Carlos, say hi. And he's helping me
Hello.
today, and he'll be monitoring the chat at all times. So keep writing your questions in chat, and Carlos or myself will get back to you at the end of the webinar. Before we dive in, I would like to clarify that today's focus will not be on teaching you how to write code in Python. Instead, we will demonstrate how easy it is to use the inbuilt Python module and scripts in StarSteer, even for those who are not coders. In a future webinar, we will cover the basics of Python and how to write code using its syntax. Also, today's session is not a click-along session, like many others of the ROGIU trainings and webinars. So just sit back, relax, and watch me play with my tools here. Let us begin with an overview of what we will cover today. So I'll start with the basic definition of what is Python, and we will see how we can use it in StarSteer. Then I will show you how to install ROGIU Python libraries. And I will introduce you to Python module, syntax, and template. Python scripts database, I'll show you how to access it and how to download scripts from there. I will briefly show you how to import and export Python scripts in StarSteer. Last but not the least, I'm going to demonstrate the top 10 most in-demand Python scripts. Let's get started. So, what is Python? Python is a high-level interpreted programming language celebrated for its clear syntax and readability. The block codes in Python are really as simple to read like you're reading a sentence in English. Python supports multiple programming paradigms, including procedural, object-oriented, and functional programming. With a vast standard library and a robust ecosystem for third-party packages. Python has a versatile applications, particularly in geoscience workflows in StarSteer. We are going to talk about some of those libraries shortly. In StarSteer, Python can be used for scientific calculations, data analytics, data visualizations, automation for repetitive tasks, such as import and export in bulk for different objects in StarSteer. We can organize our projects better by putting them into folders, and we can manipulate data as we wish. And recently added functionality for well planning, we can now do stick operations in Python. I just searched for top programming languages in 2024, and here are the results. You can see Python is on the top because it's easy to use and it's user-friendly. This is the reason we have chosen Python to have an inbuilt module inside StarSteer so that our users can use it easily and make most out of it. So now I'm going to show you how to install ROGII Python libraries. I will simply share my browser screen. and I will go to ROGI's knowledge base. The address is simple. It's kb.solo.cloud. Once you're here, just search for Python, and I will quickly log into my Solo account. Under Python calculator, you will see Python scripts database. And then I will click on the link for installing and troubleshooting ROGI Plotly package. This is the link that you need to click to install Python libraries. You don't have to do it now, but I'm just showing you this is where you can find the ROGI Python libraries. Once you click on this, a file like this will be downloaded. There you go. So I will just double click on the file. An installer will open. It is important to mention here that the destination folder by default is under app data, local, and StarSteer. I recommend you guys not to change the destination folder. And if you do, make sure that you copy everything from that folder into this particular folder. And the reason is most of the Python scripts that we have in StarSteer have a link to this particular folder to find the libraries. So in case you change this path, you will have to change the path inside most of the StarSteer Python scripts. So it's better to leave it as it is and hit extract. Once the process is completed, you are all set to use Python inside StarSteer. Now, let us get familiar with the Python module in StarSteer. So I've opened a blank Python project, and on the top ribbon, I will just click on Python, and then there is a snake-like icon here. You click that, and there you go. This is the Python module, and let's get a bit more familiar with what we see here. This is a snapshot of the same Python window. So let's get familiarized with different sections of this window. On the top left, we've got a syntax folder, and it has been categorized into different categories. You can see logs, mudlogs, wells, etc. I'll talk more about this in a moment on what the syntax is. On the bottom left, you can see templates. So these are the ready-made templates that StarSteer users can make use of, and they're again organized inside folders and by category. On the top, center top, we've got the description window, and this is a brief description of what a particular script does. In the center, we have got the variables section, and this is where you will input. You will either drag or drop or type in here under the values column. So this is the only place the user will be doing inputs. Next one is the code section. This is where the Python script resides. So either you're using the ready-made templates or you're writing your own. This is where the code will live. The next one is the console window, and this is where all the results of your script will be shown. Also, the error messages, if something goes wrong with your script, the error messages will be shown here in the console. At the bottom, you see these small icons. The first one is to import scripts. The next one is to export. And then we've got 3 buttons to hide and unhide the description, the variable, and the code section. And finally, there is a run button. I will switch back to StarSteer to get you familiarized a bit more about the module. Under the syntax folder, there are different categories. So let me show you one. Let's look at the wells category, wells syntax. We've got all the methods written under this wells syntax, and it shows everything with what you can do with the scripts. For example, in the beginning, we've got the variables defined. We can use these methods to create and delete wells. We can add or edit to the trajectory points using these methods. We can change the trajectories data inside the wells. This is how we get the well, and so on and so forth. You can see that there are some grayed out comments. So these are not part of the code, and they are actually explaining on what these methods can do for you. Same is the case for rest of the syntax for other objects in StarSteer. Under the templates, we've got various different categories. For example, completions, how to import completions. There is a script for that. Then we've got a data analysis folder. You can see that there are several scripts inside them. If you want to read more on what each script does, you can go ahead and read the description. There are scripts related to drilling, exporting and importing data. We also have a geosteering simulator. That actually is quite helpful if you have got new team members or if you want to practice geosteering skills. The geosteering simulator will actually load data at different intervals, and you can geosteer as if you are streaming live data. So very good for practicing your geosteering skills. We've got a grid operations folder, image log operations, importing trajectories and top sets, etc. And we've got interpretation operations, log operations, petrophysics, recently added sticks. We can now do well planning, and as you can see, you can bring in, import or export sticks from CSV or shape files very easily. We've got top operations and visualizations. The way we use the scripts is we select a script that we are interested in. For example, let me take one from interpretation. Let's say create sidetrack. I will just copy this and paste it under the favorites. This is now ready to use. We have done this intentionally. The templates are not changeable so that there is no chance of unintentionally changing the scripts here. So all your templates are safe. You can just copy and paste it here. If something goes wrong here in your scripts, you can simply delete and copy and paste again from the templates. All right. Let's see what next. Python scripts database. So I will quickly show you how to access ROGII's Python script database. So back to knowledge base, click on Python script database, and you will see that all the scripts are listed here under the categories. Notice that some of the scripts have got 3 statics before their name. These are web-only scripts. These scripts are not available in the standard install of StarSteer, but you can come here and click on this to download. Once you have downloaded these scripts, let us now look at how we can bring those scripts inside StarSteer. So simply just click the import button, and it will open up a browser window. This can take files of type SS script, which is StarSteer script file. This is a special file, a special format for the Python scripts for StarSteer. So just select a script that you have just downloaded from knowledge base, or if some of your colleagues have sent you a Python script, simply select it and hit open. This script will appear here under the favorites folder. For example, I just imported a script that prints my object tree. Once I click run, the console will show me all the contents printed for my object tree here. This is quite handy if you've got a complex project and you don't know where a particular well or an object is hidden. So you can print your object tree like this. Let us get back and see what's next on our list. Okay, time for some action. So here are the top 10 most in demand Python scripts. So I'm going to demonstrate all the 10 scripts for you right now. Quickly, I'll show you how to create sidetracks, create drilling windows, create drilling corridors, export some logs, and import some completions data. Then we will look at how we can use average ROP in TVT scale effectively inside StarSteer. We will create a weight on bit versus ROP heat map. And then we'll do some ROP by zone analysis. And finally, we'll do some drilling exponent calculations and mechanical specific energy log calculations. Let us dive into this. I'm going to go back to the same project. What we see here is an Eagle Ford project with hundreds of wells in it. This is public data, and we've got permission from TGS to use this project for demo purpose. So like I said before, in order to use a script, I will just copy it from the templates and paste it under the favorites. I can also then drag and drop this particular script inside favorites, and this creates a shortcut here under the Python. You can create as many as you like, and your shortcuts will appear here. And you can access the script by clicking here too. Let us begin by reading a brief description of what this script does. So this script actually creates a copy of wells cropped to a specific MD so that you can stream data to a new leg or a sidetrack of the well. But before I use the Python script for doing this, let's say how we do this manually or a conventional way of doing the same thing. So I will create a new well. And then for the mother well, I'll have to go to the spreadsheet. Let us say I want to create a sidetrack somewhere around 11,000. I'll have to select all these cells. I will copy them, go to the new well that I just created, open up the spreadsheet, paste the data there. We'll have to fill all the headers again. So you can see that it's quite a tedious process, and I will have to do the same for logs and all the other objects that are contained in the well. So now let's look at the Python way of doing the same thing. So I will just open up the Python module. And I'm going to look at the inputs. So from the object tree, I will just grab the well where I want to create a sidetrack and drop it under the value for the first one. So this is our input well. I will then define the cutoff MD for the sidetrack. Let us suppose I want to do it at 11,500. And optionally, I can define the number of sidetracks that I want to create for each lateral. I'll leave it 1 for now. Here I can define the name for my newly created sidetrack. I can type in here, put something like a leg, or if I leave it blank, it is going to take the name of the original well and place underscore sidetrack underscore a 2-digit number, for example, 123, for that purpose. And then there are some true and false Boolean type questions. Whether or not I want to copy the, I would say yes for that. Whether or not if I want to copy image logs. So for now, I'm not interested in this one. For rest of the questions, I'll bring in horizons and segments. And then I'll just hit run. So you'll notice any new objects that are created by Python in StarSteer will be highlighted in your object tree. So it's easier for you to find. So a new leg has been created for me. I can turn this on. So you can see on my map view, it's appearing like this. And inside this new leg, I've got my interpretation, gamma ray log, zone log, etc., top sets. Everything is imported. And if I look at the spreadsheet, I can see that the well has been cropped to a point, to a survey point just above 11,500. The depth I chose, all the header information is there. So it's quite simple. If I need to create many laterals or sidetracks, it's just a click of a button and you've got your wells created. Let us move on to the next one. This time, from the drilling folder, I'll just copy create drilling window and paste it under the favorites folder. What this script does, it actually creates a polygon that can be used to define a drilling window for the currently active well or any well that you choose. And you must define the well plan that you want to use for this purpose, for drawing a polygon, and the MD point at which you want the window to start. And you also have to mention on what are the upper and lower bounds for the window. So this is quite helpful if you want to share with your drilling team that this is my target and you have a window of that many feet or meter above and below the well plan. So this is the window that you want the drilling team to follow as tolerance. Let us use the script now. So I can either select from map view using the lasso tool and select my well. Once I do that, those wells actually get highlighted here, and I can just simply drag and drop them here. Or you can also use the object tree and drag and drop the well. We will need a well plan for creating a drilling window, so I will just simply drag and drop the well plan. And I need to define a starting depth for my window. Let's say I want to start at 11,500. And then I can define what is the top bound for my window. Let's say 50. And the lower bound, I can type in a number here of my choosing. Once I'm happy with my selection, I will just hit run. And a new polygon has been created, it has been highlighted for me. So I will just simply go and enable this one. Under the polygon format, I can go ahead, change the color, change the weight of the line so that it's more prominent. As you can see that we have easily created a drilling window on top and bottom of our well plan. So easy to share with your drilling team, and you can share the geological targets and tell them this is the window that they need to stay inside. So quite handy. Now let's move on to the next one. This time from drilling, I will copy, create drilling corridor script and paste it under the favorites folder. Let's look at the description on what the script does. This will create another polygon, but this time it will be a horizontal corridor around the wellbore, and this will help us to stay within optimal geological and engineering parameters, and on horizontal scale, we can stay within particular wellbore trajectory. Again, we are going to need an input well. Let's use the same well for this and drag and drop the well plan. Define the start of the corridor. This is the measure depth for starting the corridor, and define the width of the corridor. As simple as that. Once I'm happy with my selection, I'll just hit run. A new polygon has been created for me. So to view this, let's switch to map view, and I will enable this, make it more prominent. I'm just going to go to my format, use a different color, choose a weight, and there you go. You've got a new drilling corridor created around the wellbore trajectory for the well plan. So easy for sharing with your drilling teams and to follow a particular drilling corridor. Let's check out the next one. Let's say we are interested to export some logs and share with the rest of our team. So again, I'll just grab the well from the object tree, and this is the output path where I want to save my exported CSV files. I can either type in the path or click on these three little buttons to open up and choose a path. So let's say I'm saving it in my C drive under a folder called work. Remember, we are not selecting file, we are selecting a folder. Define the data precision for the logs and simply hit run. And you'll see the message that files have been created, and this is the path you can find them. In the object tree, you can see what logs were exported. Let's look at them. So I'll just go to C work. This is where I told Python module in StarSteer to save my files. And there you go. Here's my exported ROP log, MD and ROP values. Similar for the gamma ray log. I've got the saved MD and value for gamma ray. So as simple as this, let's say you have lots and lots of logs that you want to export and share with your team. With a simple click of a button, you can export all of them and send to the rest of your team. So quite simple to export logs. Let us dive into some completions import. So for this, I'll choose a different StarSteer project where I want to import some completions data. So here is an Excel file where I've got the completions information. I've got the frac stages, top and bottom for each stage, and some other parameters related to completion that I'm interested to bring into StarSteer. So what will do is I'll go to Python, go to completions, copy the completions import script and paste it under favorites. So what this script is going to do, it is going to create completions brick logs and stages topset from a CSV spreadsheet or an Excel. So what are the inputs required? We need the file path for where we from where we want to import the data. Again, simply double click and click on those three little dots and navigate to the path where you have saved the completions data. And then let me put this on side and bring the Excel as here as well. On the right-hand side. So the first question is about define the column from where Excel, from the Excel spreadsheet with the top values for the stages. So it's located under E column. So I'll type in E here. For the bottom of the stages, it's stored in F. I'll put the column name or number here, F. And then this is a dictionary, and this is the data that we want to bring in. For example, I want to bring in breakdown pressure stored in H column. So I will just put the name of the column like this, followed by a semicolon, and the column name or number, which is H in this case, under inverted commas, and any other parameters that I want to import. So in this case, I want to import the total fluid volume. So you can put in as many parameters as you want to import. The next question is whether or not I want to visualize the stage numbers as top sets. So I'll say yes for that. This is a Boolean true or false question. And then I have to define the column in Excel spreadsheet with the stage numbers. So in this case, the stage numbers are defined in column C. This is the name that I want to give to my output topset name. So I've given it stage topsets. And this is the prefix that will be used for each stage. So I can type in any text that I want here. And then I need to define the starting row where actually the data is starting. So my data is starting from row 6. So I'll put 6 here. I can drag and drop the well name like we were doing it before, or leave it as it is to active lateral name. So it will take the well that is currently active, and I'll just hit run. You can see 2 new logs have been created for us. Let us look at them. I will just add a new track, and I will add these 2 here. So one by one, I can then choose to fill, let's say, with this color, and the other one with a different color. So we've got our breakdown pressure and total fluid volume plotted here. And I've got the stage numbers imported under stage topsets, so I can just enable them, and all my stages are appearing here now. So I can clearly see all the completions data imported for me. So these stage numbers are here along the wellbore trajectory and on the horizontal and vertical tracks. The stages are mentioned as topsets, and the data for breakdown pressure and total fluid volume has been imported for us. So it was as simple as this. Back to my StarSteer project. This time, I'm going to look at some drilling related Python scripts. So first one, let us look at a script that calculates the average ROP in a TVT scale. So let's see the description for this. This script basically calculates average ROP or any other log from horizontal log in TVT space. So this is a TVT log. In this case, it's an average ROP, and the output is generated as a vertical type well log, which you can then plot off, and you can choose RPM cutoff parameter to ignore the sliding intervals. So again, for inputs, I need to define a well name. I'll just drag and drop from the object tree my desired well 4 in this case. And then I have to bring in ROP and RPM logs. So simply from the logs for this well, I will just drag and drop ROP and RPM logs. This is the RPM that I want to define as cutoff. Let us suppose anything below 20 RPMs, I'm going to ignore it as sliding interval. Then I will choose a type well under which I'm going to create these new logs. So again, from type wells, just drag and drop the type well. And this is the name of the output log. So I've called it ROP lateral. And optionally, I can choose the sample rate for my new logs. Once I'm happy with my selections, I'll just hit run. So Python is doing calculations in the background. And there we go. The console says log ROP lateral has been created, and the new log is highlighted in the object tree. Let's see what's the best way to make use of this. I'm going to turn on my target top and base horizons. I'll go to horizon format, and under the horizon fill, I will find ROP lateral and fill my horizons with the newly created ROP lateral TVT log that I just created. So I can now easily identify the layers of faster and slower ROPs. So this can help me optimize my well placement and place my well in the sweet spot. So quite helpful, an easy way to fill in horizons with TVT, average ROP in TVT format. Let's check out what's next on our list. We are going to look at ROP by zone analysis now. This is located under visualizations folder, and you can just copy from here, paste it under favorites like we were doing before. And let's look at what this log is going to do for us. So this script will take the active well and the interpretation and calculate the average RP within each zone based on that interpretation. And you also have the option to specify ROP cutoff like we did before to ignore sliding, or keep sliding and rotating separately. So the script as an output will show us some group bar charts with the results of analysis. So let's see how it looks. From the object tree, again, I will choose a well. Simply drag and drop here. I'll choose an interpretation. If I have multiple interpretation, I can actually run the script several times to see my zone analysis by RP for different interpretations. So drag and drop the interpretation here. Type in or drag and drop the ROP log name. Set a cutoff below which you will consider drilling a slide, and then hit run. And a new browser window will open up, which which will show your average ROP broken down into rotating and sliding, separated by different formations. So you can zoom in any area of interest by simply using the left click of your mouse. You can double click to go back. Click on this camera icon to download this plot as a JPG or PNG file, which you can simply share with your team, copy paste in emails or PowerPoint slides or whatever. You can also edit this plot by clicking here. So simply, you can choose new themes or the appearance. For example, under themes and styles, I have chosen a dark theme here. So you have a number of options to customize your chart. Again, once you're happy with editing, you can take a snapshot and you can share with your team. Quite easy to create these visualization. I would like to mention here that we are using Plotly, the third-party library, which we installed as part of our installations of Python libraries. We are using the script to show it, but I want to clarify that none of your data is being uploaded to internet. So all your data is still offline, and we are just using the browser window to showcase your visualization. So here is the ROP chart. Here is the ROP chart for another one. For another project, you can again zoom in on any of the areas, double click to go back. So those were your ROP by zone analysis. Let us now look at another one, the heat map one. This will be creating a heat map between weight and bit and RPM. So again, from the well, we'll drag and drop the RPM, weight on bit, and ROP. Those are the inputs. And then we've got some visualization optional inputs. You can use these to customize your chart. You can choose the minimum and maximum TVT. Once you're ready, just hit run. And this will again open a browser window. Here we go. So we can see the combinations of weight and bit and RPM that can give us the maximum ROP. So you can, again, zoom in a particular area and read the weight and bit and RPM values that can give you the maximum ROPs. So quite handy to optimize your drilling parameters. You can do this for number of wells and find out the best combination for weight and bit and RPM for each depth interval or for each formation. Now let's do some d-exponent calculation. Drilling exponent or d-exponent, it actually calculates, is used to monitor formation pressure changes and helps us to adjust drilling parameters accordingly. So we are going to create a new log by using the input parameters. So again, just define the well name, ROP, RPM, weight and bit. Define the bit size and the step for the d-exponent log. And you can define your own name for the d-exponent and hit run. And you can see that we have created a new log. Let us activate this well. Let me remove these logs for now. And I'll just drag and drop the newly created d-exponent log. Come out of the geosteering. I can fill up the d-exponent log with the choice of my palettes or colors, and my d-exponent log is plotted here. So this is how simple it is to use Python and create some new logs, do some new calculations. Finally, I'm going to show you how to calculate MSE, mechanical specific energy. That helps us assess the drilling efficiency and helps us optimize drill bit performance and drilling practices. So we will again drag and drop the well name. The inputs required for calculating MSE are weight on bit, RPM, torque, and ROP. So we will just drag and drop the relevant logs here or just type in the log names. We need the area of the hole. So I've used the hole size to calculate the area. So I need to put the area here. Again, I can define an RPM cutoff for ignoring the slides, and then give a name to my log, and then hit run. A new log has been created for me, which I can simply drag and drop and show here. So we can now clearly see the peaks of MSE and whether or not we were drilling efficiently, or was it time to pull out the bit? Were there too many vibrations downhole? We can monitor MSE and make informed decisions for pulling out of the hole. So that was all. I have reviewed and demoed all the top 10 Python scripts. I hope you enjoyed the demo today. So let's make the most of the Python module in StarSteer. Let's use it and make the best out of it. If you need any help using this, these are on the screen. You can see our support email and support line numbers for US and Canada. Do get in touch and keep an eye on our social media platforms for an upcoming webinar about writing your own Python codes using the templates that I showed you today. So I am now open to any questions, and I would request Carlos to pick 2 or 3 questions so that we can answer it in the remaining 8 minutes.
Okay, well, thank you, Ali, for really well done webinar. We have a question about if it's a way to create dynamic log using Python.
Definitely, we do have scripts for that, and drop us an email on the support line, and one of our team members will be able to help you on how to create dynamic logs. Also, creating dynamic logs is quite simple, even without Python scripts. So one of our team members can actually walk you through the process or workflow creating the dynamic log. Thank you for the question.
Yeah, we have another one. They say sometimes they deviated so much from the plan. So in this situation, instead creating a script drilling for the window, respect to the plan, would be better to generate either target line or target window created by target horizon. What's your advice about that?
We have Python methods and scripts for calculating the deviation from well plan. Recently, there was a request for calculating deviation from target line. So this is quite doable, and we will need a custom script for this. The way it works is we have some templates, and we also have some web scripts that I showed you in the beginning. Also, if you have some other great ideas or workflows that you want us to have a Python solution for that, do get in touch, reach out to us on our support email, and our team will look for if there is an existing script that can do the job. If not, if it's a simple task and can be done in 3 to 4 hours, our support team is going to help you with that. If it's a big project, we are going to raise a user feature request. And this request goes to our Python development team. They are going to prioritize based on the demand for that particular workflow. It is either written on the templates for upcoming StarSteer releases, or if it's a company-specific script, our Python's team can develop a custom script for your company, for your workflows. So this is the process of getting new requests for Python scripts.
We have another question. It's not Python related, but is if we have any free data when you're testing the software that they can use.
Yes, we've got some sample projects. We normally use them for our intro to geosteering course. But if you guys are interested to practice geosteering, we can share those projects with you so that you can practice the Python scripts on that. We can definitely share with you. So just get in touch with us and we'll be able to guide you on how to get some sample projects, sample data.
And also, if I may complement that one, when you downloaded the StarSteer, when you installed the software, inside the zip file is a sample project too. So you can drag and drop the sample project on top of StarSteer, and that works too.
That's a great point. Yeah.
Is there any open console notebook embedded to write their own scripts?
Definitely. So you can write your own scripts. Let me show you how you do it. Just open a new script and you're good to go. You can write your own scripts in the code window. So let's say I want to say, hello, StarSteer world. Hit run. There you go. The result is there. So you can write your own scripts here. As I said, it was beyond the scope of today's webinar to walk you through how to customize scripts or write your own scripts, but you can do that. If you know how to code in Python, simply go to the syntax, see what you want to do. You can even copy this, and if you're a ChatGPT user, just tell ChatGPT using this script, write me a function or a script that does this, and come here, make a new script based from ChatGPT results, and boom, hit run, and your results are there. Another example, let's say you can do simple mathematical calculations here in Python. Let's say I've got two variables and I just want to sum them up. So I can just come here and say print x plus 1. And there's my result, 11. So you can write your own scripts. And as I said, we will do a future webinar where I will walk you through some basics of Python and show you how you can modify the existing scripts or write your own scripts. Keep an eye on our LinkedIn and Eventbrite pages. Hoping to have that webinar really soon. One more question, Carlos. You've got only 1 minute left.
Let me see. That will be wonderful to write our our own scripts and can still wonder if we can estimate an isopath grid by doing some grid operations.
Yeah, you can write your own scripts, and whatever comes to your mind, you can play with different objects inside StarSteer. The data is yours to play with. Several ready-made templates, lots of syntax. Just check out what you're looking to do. If you need help, reach out to us. We are here to help you guys customize your scripts or troubleshooting the scripts that you have written. All right, this brings us to an end. I want to thank you all once again for your interest in using Python and StarSteer. Until next time, thank you very much. Take care of yourself. See you next time. Bye-bye.